Okay, continuing on with section 7.6, the rational root theorem. Number 4 says find all rational zeros of the function x to the fourth plus 10x cubed plus 33x squared plus 38x plus 8. Okay, so when I list my possibilities p over q, I said you could shortcut it. You could say the possibilities for p were factors of 8, so 1, 2, 4, and 8. Possibilities for q are factors of 1, so just 1. Okay, so that means I have 8 different possibilities. I have 1, 2, 4, and 8, and I have -1, -2, -4, and -8. Okay, let's try the smallest one. So let's try 1 first. So I have 1x to the fourth, 10x cubed, 33x squared, 38, and 8. Drop the 1. 1 times 1 is 1. Add straight down, I get 11. 1 times 11 is 11. Add straight down, I get 44. 1 times 44 is 44. Add straight down, I can already tell I'm getting too big. Did you guys see? All right, so this 1 didn't work. Now that should make sense. I should have thought this through. Notice how if I plug in 1, I would have just one big positive answer. If I plug in 2, I'm going to have one big positive answer. You're not going to get 0 out when you plug in a positive number because all of your signs are positives here. So that means we have to plug in a negative number. So let's try -1. So 1, 10, 33, 38, and 8. So -1 times 1 is -1. Add straight down, I get 9. -1 times 9 is -9. Add straight down, I get 24. -1 times 24 is -24. Add straight down, I get 14. -1 times -14, or times -1 is -14. Add straight down, I don't get 0. So that doesn't work. And notice how I'm always just crossing these out. I want to know that I've tried these. I don't want to erase because sometimes you have to try several things. So it's good to see what you've already tried. Drop the 1. 1 times -2 is -2. Add straight down, I get 8. -2 times 8 is -16. Add straight down, I get 17. -2 times 17 is -34. Add straight down, I get 4. -2 times 4 is -8. Add straight down, I get 0. Okay, there I am. So this means I factored into x plus 2, change the sign, times x cubed plus 8x squared plus 17x plus 4. Now, although this has 4 terms, you'd think that you can factor by grouping on this, but you can't because you could pull out an x squared, you'd have x plus 8 left. And when you pull out what they have in common over here, you don't have x plus 8 left. So you actually can't factor by grouping all the time when there's 4 terms. It's nice when you can, but... So we need to try something else. So let's try the next -1. So let's try -4. I'm going to try it in my factored form. So I'm going to try 1x cubed plus 8x squared plus 17x plus 4. Drop the 1. -4 times 1 is -4. Add straight down, I get 4. -4 times 4 is -16. Add straight down, I get 1. -4 times 1 is -4. Add straight down, I get 0. So I've now factored into x plus 2 from before, x plus 4 from my divisor right here, and then x squared plus 4x plus 1. X squared plus 4x plus 1 actually doesn't factor. It's something you need to use the quadratic formula on. Now, since mine said find all the rational zeros are going to be things that you can factor. Irrational numbers are going to be the ones where you can't factor, you can only use the quadratic formula. Or complex numbers, so things that have I. So if I told you to find all zeros, then you need to go further and you need to use quadratic formula. But since I said find all rational zeros, my rational zeros are just x equals -2 and x equals -4. That's it. So my rational zeros would have been from my original possibilities, so from these numbers. Okay, so I know I'm done. So those are my 2 rational answers. All right, next one. So it says an open box is to be made from a square piece of material with side length 10 by cutting equal squares from the corners and turning up the sides. Okay, this is a typical math problem. These are always, I mean, we have these in calculus all the time too. So I have Oh, I started out with a square piece of material. Let me make it a square first. Okay, so it's 10 inches on each side. And I'm going to cut little squares out of the corners, and I'm going to fold up the edges. Okay, so see, these corners are now gone. So I cut them out. So do you see when you fold up these little flaps here? It's kind of hard for people to see. So I'm folding up this flap. I'm folding it upwards. So now when I do that, I have like this real shallow box, kind of like a gift box. So it looks like that. Okay, so we need to think about what each measurement is. So it was 10 before. That's from all the way to those corners. So if I call this x by x, so the corners, this length on the inside here, so this green length, I had 10 before, but I cut out 2 x pieces. So that green length is 10 minus 2x. Same thing for here. So it's 10 minus 2x and 10 minus 2x. But then the height isn't 10 minus 2x. So if you see when you folded up these flaps, the height is, let me draw it in black, maybe you can see it better. It's right here. So your height is x. Okay, so that means my volume, the volume is always length times width times height. So my length and width are 10 minus 2x, and my height is x. Okay, we want the volume to be 48 cubic inches. So let's make it equal to 48. Okay, I'm going to FOIL out. So I'd have 100. My outer and inner are both negative 20x, so I get minus 40x. My last is plus 4x squared. And I have to multiply all that by x. So I get 100x minus 40x squared plus 4x cubed. And I have a 48 on the other side. So I'm going to try to get everything on one side. So I'm going to just subtract the 48 over. So I have 4x cubed minus 40x squared plus 100x minus 48. Okay, try to make things as easy as possible. Like you can pull out a 4. So now your numbers are at least a little bit smaller. So when you do your P over Q, we're just working with this polynomial, not with the 4. So my possibilities for P are factors of 12. So 1, 2, 3, 4, 6, and 12. My factors of Q are just plus or minus 1. So at least I didn't have plus or minus 1, 2, and 4 from before. Okay. So basically I'm trying to solve for x. So x is going to be the height of the box. I know it's probably not going to be 12 because you only had a 10-inch side in the first place, so you're not going to cut out 12 inches from both pieces. So it's not going to be that. It's not going to be 6 for the same reason. You can't cut out 6 and 6 and have any length left. It's probably also not going to be 4, but it could be. I mean, you could cut out 4 inches from the right and 4 inches from the left, so you never know. So let's try, I don't know, you could try one. I'm going to guess, let's try 2. So I'm guessing it's probably 2 or 3. So I'm going to have 1x cubed, negative 10x squared, plus 25, and then minus 12. Drop the 1. 2 times 1 is 2. Add straight down, I get negative 8. 2 times negative 8 is negative 16. Add straight down, I get 9. 2 times 9 is 18. That's too big. Don't get 0 out. So that one's gone. So let's try 3. Drop the first term. 3 times 1 is 3. Add straight down, I get negative 7. 3 times negative 7 is negative 21. Add straight down, I get 4. 3 times 4 is 12. Add straight down, I get 0. That's what we wanted. So that means that I'd have x equals 3. So I have a 4 out front, x minus 3, and then it factors into x squared minus 7x plus 4. So the first answer is x equals 3. That's one of them. Now, the other answer is you could use quadratic formula here, because I didn't say it had to be a rational number. I mean, I could have 1 plus the square root of 2. You never know. So you need to use the quadratic formula there. So x equals negative b, so 7, plus or minus square root of b squared. So b squared would be 49 minus 4ac all over 2 times a. So I get 7 plus or minus 49 minus 16. So 23 all over 2. So there's 2 answers there. We'll grab my calculator real quick. Okay, so I use my calculator to find the 2 answers. So when I do 7 plus or minus the square root of 23 over 2, I get 2 answers. The first one's 5.898 and 1.102. Now, the 5.898, that's almost 6 inches. So that one wouldn't make sense. You can't cut out a 6-inch square from both sides of this 10 inches. So that one's gone. But this 1.102, although it's not a very nice number, I mean, I wouldn't want to cut out 1.102 inches. I have no idea how to precisely cut that. That could be a possible solution. So that could also be an answer. So I would circle that one as well. Okay, so it's either 3 inches or 1.102 inches. So that's just kind of a weird question. Really, if you just had 3 inches, I would probably count that right if it was on your test. All right, and then the last one, the irrational root theorem just says if the polynomial p of x has rational coefficients and a plus the square root of b is a 0, then a minus the square root of b is also a 0. Similar to the complex conjugate root theorem. Basically, if you have a square root answer, you need to have its conjugate as well. Okay, so identify the roots of 2x cubed minus 9x squared plus 2 equals 0. So do your p over q. You get plus or minus 1 and 2 over plus or minus 1 and 2. Let's try 1. 1 times 1 is 1. Add straight down and get negative 8. I can already tell that one's not going to work. Let's try 2. 2 times 2 is 4. Add straight down and get negative 5. 2 times negative 5 is negative 10. Doesn't work. Let's try negative 1. 2 times negative 1 is negative 2. Add straight down and get negative 11. Not going to work. Negative 2. 2 times 1, or negative 2 times 1 is negative 2. Add straight down and get negative 11. Too big again. So, oh, sorry, 2. So negative 4. So it's still too big. All right, so those numbers aren't going to work. So 1, 2, 1, and negative 2 don't work. Let's try 1/2. 2 times 1/2 is 1. Add straight down, I get negative 8. 2 times, or 1/2 times negative 8 is negative 4. Add straight down, I get negative 2. Let's try negative 1/2. Last choice. Negative 1/2 times 2 is negative 1. Add straight down, I get negative 10. Ah, did something very stupid. Did you guys see what I forgot to do? I forgot to add in my 0. No wonder this is not working for me. One-half times 2 is 1. Add straight down and get negative 8. 1/2 times negative 8 is negative 4. Add straight down and get negative 4. 1/2 times negative 4 is negative 2. Add straight down and get 0. So 1/2 does work. So it's x minus 1/2 times 2x squared minus 8x minus 4. Let's see how much time I have. Okay, when you use quadratic formula on the other one, I'm running out of time, so I'm going to pause this and I'm going to do that off to the side. Okay, so when I find my answers, I'm going to use quadratic formula. I get 8 plus or minus the square root of 96 over 4, which reduces down to 2 plus or minus the root 6. So there's 2 answers there. That's the irrational root theorem. 2 plus root 6, 2 minus root 6, and the last one was the 1/2 from before.